Which one? She woke up.
Before we begin the session, we are going to try to put together a group photo for Barry's desktop purposes, which we will try to do after Tim's talk. So if y'all can stick around right after 5:30-ish, whenever Tim's talk comes to an end, we'll all come to the front and try to make that happen.
Maybe you can try people in their seats.
We can picture now or just bunch of pictures?
Well, we're all, so as Jill was saying earlier, please all continue to take pictures now and we'll try to collect pictures.
But I have a self-referential problem. I can't take a picture of each time I get to use the timer.
Serve you if you can.
There is a thing now.
I get it.
Phones. Sean was going on about phones, having all these phones can also delay pictures.
Phones can be self.
Yeah.
Very on the floor. Yes.
Barry is in the building.
We have the guiding rule that no rules apply to Barry.
This isn't a change.
It's just a Monday your day instead of de facto. So we fought these facts for too long.
Silence yourself.
Yes. Try to avoid reply all.
Yeah, right. Yeah, please don't hit reply all.
All right, well, while we're waiting for Barry to arrive, Lisa and Choi will be chairing our final session. So Lisa, I'll turn it over. Penultimate session.
I did finish it, but now to start, or do you want to wait for Barry to?
Barry's here. If you begin, he will come.
Is that a negative interference effect?
Okay, after David talk, we can now see how Barry's culture turns out. So please welcome.
I'm very happy to join you all in paying tribute to Barry by talking about a topic that's in his wheelhouse and that many others who are here have also written. But as for Barry himself, you know from David yesterday that Barry and I are half second cousins, which doesn't mean we're first cousins. And in the spring of 1984, my mom asked cousin Barry for help, try to persuade me not to go into philosophy. And Barry did come down to Princeton, where I was an undergrad, and we met for the first time since I was an infant. And we had, as I recall, a very nice lunch together. As I remember it, I talked a lot about the courses that I was then taking from David Lewis and Bas van Frost. And if I had known that these were two big-time philosophers, I would have been much shyer in those classes. But happily, Barry did not tell me that. And this was while he was also not telling me to avoid going into philosophy. And I'm very grateful, Barry, for your masterful inactivity on that occasion. My mom was not as grateful. She was not happy with Barry. Though I learned later that she was under a misapprehension about Barry's job. Barry's father had often said to her that Barry made a living by delivering papers. I think my mom had the impression that he had a kind of bike route.
Can I interrupt? You can see where I got my sense of humor from.
So, the handouts.
This
It would be good to. The title of my talk incorporates the phrase "the rule of law." And by that, I mean the idea that the laws of nature require non-modal things to be certain ways. Things must conform to the laws of nature. The laws are binding, they're inescapable. In particular, if it's a law that A, then A is the case. And accounting for this entailment is what von Frosten calls the inference problem. My ambition in this talk, with a certain amount of hubris, is to give my solution to this problem. But first, I want to say something more about the problem itself and about what it would really take to solve it. And that alone will be more than enough to get me into plenty of hot water. As all of you know, according to the Dredske-Armstrong-Thule, the DTA account, a law is a special sort of relation holding universals, what DTA call a nomic necessitation relation. David Lewis famously objected that this approach leaves the inference problem unsolved, and I put a passage from Lewis first on your handout. On the universal's view of lawhood, Lewis says, quote, "It's somehow necessary that if a nomic necessitation relation N holds between Fness and Gness, then we have the regularity that all Fs are G. I ask, how can the alleged lawmaker impose a regularity? Why can't we have NFG and still have Fs that are not G? What prevents it? The fact that N is called nomic necessitation must not be allowed to obscure this problem. The universal's account cannot just posit that NFG guarantees that all Fs are G. Rather, the DTA account must describe N so as to explain why this inference holds. That's Lewis's point in the next oft-quoted passage on your handout, where he writes, quote, "It's no good just giving the lawmaker a name that presupposes that somehow it does its stuff, as when Armstrong calls it necessitation. If you find it hard to ask why there can't be Fs that are not Gs, when Fness necessitates Gness, you should ask instead how any relation among universals can do what N must do to deserve that name," unquote, the name being nomic necessitation. Lewis thinks that N cannot deserve to be called necessitation because of the metaphysical gulf separating universals from particulars. He writes, again on your handout, quote, "Whatever N may be, I cannot see how it could be absolutely impossible to have NFG and FA without GA. Unless N just is constant conjunction or constant conjunction plus something else, in which case Armstrong's theory turns into a form of the regularity theory he rejects." Here, Lewis implicitly suggests that any regularity account of lawhood, such as his own account, would solve the inference problem. Von Frosten agrees and says that if M's lawhood consists of M's belonging to the best system of truths, then obviously M's lawhood logically entails that M is true. I don't think that's right, or at least I don't even think that it's von Frosten's own considered view. He points out that although A's standing in the N relation to B does not logically entail that all F's are G, the universal's account could include an extra premise that there is this connection between the nomic necessitation and the regularity. However, von Frosten says, again on your handout, quote, "It would be very disappointing if that extra premise asserts the connection and does not explain it," unquote. I agree. Such an extra premise would be cheating, theft over honest toil, and all that. But then the inference problem cannot be merely to secure the inference from lawhood to truth, even though that's what von Frosten officially says it is in the next passage on your handout. The inference problem must also be to explain that connection. Lewis similarly says in the second passage on your handout that the universal's account fails to solve the inference problem because it fails to explain why there can't be F's that are not G's when F-hood nomically necessitates G-hood. To give such an explanation, it seems to me, universal's account would first have to characterize the N relation in some way that's independent of that relation's explicitly guaranteeing the regularity. The account would then have to show that this guarantee follows from that independent characterization of the N relation. For that matter, it seems to me that it's debatable whether even a regularity account of lawhood really explains why lawhood entails truth. A regularity account builds truth expressly into lawhood. The laws just are whatever truths, individually or collectively, possess the extra non-modal something that distinguishes laws from accidents. A regularity account does not first characterize M's lawhood independently of M's truth, and then show how M's lawhood, as so characterized, ends up requiring M to be true. A closely related desideratum for a real solution to the inference problem is that it metaphysically explain how M's lawhood can scientifically explain why M is the case. This sort of scientific explanation is very familiar. The law of energy conservation, for example, explains why no one has ever succeeded in building a machine that increases the world's total energy. But if M's lawhood just consists in M's truth plus something extra, then how does M's lawhood scientifically explain why M is the case, without M being explained at least partly by M itself? That's an old chestnut, and I don't really want to get into it here, because I've never managed to get out of it, except to mention that a solution to the inference problem might be expected to shed some light on how the fact that M is a law acquires the power to scientifically explain why M is the case. One way that M's lawhood entails M's truth should be the way that M's lawhood scientifically explains why M is true. So a solution to the inference problem should tell us how laws come to possess their power to explain in science. A solution to the inference problem should tell us in virtue of what M's lawhood scientifically explains M. In sum, the inference problem, as I see it, leaves us with a dilemma. If there's too wide a metaphysical gulf separating M's lawhood from M's truth, then any attempt to cross that gulf will fail, or we'll have to rely on ad hoc connections having no metaphysical explanatory power. On the other hand, if M's lawhood is too near to M's truth, then M's lawhood cannot scientifically explain why M is the case, and the rule of law becomes trivial rather than part of the majesty of the laws. Now, I know what you're thinking. Anything will inevitably be either too near or too far. There's just no pleasing some people, people like me. Well, we'll have to see if I'm being unreasonable in my standards for a proper solution to the inference problem. Let's turn now to natural lawhood. As you know, there are many proposed philosophical accounts of natural law. There's the Bill Ramsey Lewis, or MRL account, also known as the best system account, or the BSA. There's the Dretske-Tully Armstrong account that I've mentioned, the DTA. And there's Barry's own package deal account, the PDA. I'm going to talk about one more, my own account, the BLT. That's the big Lange theory. Now, the motivation for the BLT comes from the difference between laws and accidents in their relation to counterfactuals. For example, the laws of combustion would still have held, even if I had struck the match, but the accident that all of the matches in the matchbook are unlit would not still have held if I had struck the match. A rough way to generalize this idea is that for any truth M, it's a law that M, if and only if, M would still have been true under any counterfactual antecedent that's logically consistent with all of the laws. However, this idea obviously uses the laws themselves to carve out the range of counterfactual antecedents over which the laws have their distinctive invariance. In that case, we can explain what's important about the laws only by first identifying what's important about invariance under this particular range of antecedents, which we can do only by presupposing that this particular range is important, and hence that the laws are important, which takes us completely around a rather tight circle. The BLT aims to avoid this problem by characterizing the set of laws as special by virtue of its stability. Roughly speaking, a set is stable exactly when it's a logically closed set of truths, all members of which are invariant under every counterfactual antecedent that's logically consistent with its members. The BLT says that the set containing exactly the laws is the largest stable set, apart from the set of all truths. No counterfactual antecedent is logically consistent with the set of all truths. So that set would be making an empty boast by bragging about its invariance under every single counterfactual antecedent that's logically consistent with it. This maximal set is trivially stable because there's no counterfactual antecedent where the set's invariance under that antecedent is required in order for the set to be stable. On this picture, M's lawhood partly reflects what the other laws are. since they help to delimit the range of counterfactual antecedents under which M must be invariant in order for M to be a law. So M's lawhood is not M's individual achievement, it's a team effort, just as on Lewis's account and on Barry's account. But the BLT differs sharply from the BSA and the PDA in taking the truth of various counterfactual conditionals as more fundamental than the facts about which truths are laws, and as irreducible to facts about the Humean mosaic. The BLT is a non-Humean account. According to the BLT, lawhood consists in belonging to the largest non-trivially stable set. The BLT's rough definition of stability is the next thing on your handout. A set's stability consists roughly in its invariance under every antecedent under which it could logically possibly be invariant. A set's stability consists in the sets having the greatest range of invariance that it could have. Its stability consists in its members collectively being maximally inevitable, inescapable, unavoidable. By forming a stable set, the laws deserve to be characterized as possessing a variety of necessity. In other words, the laws possess a variety of necessity by virtue of being non-trivially invariant under every counterfactual antecedent possessing the corresponding variety of possibility. For every non-trivially stable set, there's a corresponding species of necessity. For example, the logical truths form a stable set corresponding to logical necessity, just as the natural laws form a stable set corresponding to physical necessity. The concept of stability thus avoids using the laws per se to carve out the law's characteristic range of invariance. Whatever set it is, the stability of which is being judged, that set gets to carve out for itself the range of antecedents under which it's got to be invariant in order for its members to be exactly the truths with a distinctive variety of necessity. What about the iterated or nested conditionals in the definition of stability? What do they have to do with the law's invariance under counterfactual perturbation? The nested conditionals ensure that for any physical possibility Q, all of the conditionals required for the law's stability would still have held, had Q been the case. Therefore, if Q had been the case, the set of actual laws would still have formed a stable set, and so the actual laws would still have been laws. In this way, the BLT accounts for the fact that had the accidents been different, whatever would have happened would have been explained by the actual laws, since they would still have been laws. For instance, if the Earth's axis had been perpendicular to its orbital plane, then there would have been no seasons on Earth, but the actual laws would still have been laws, and therefore they would have helped to scientifically explain why there are no seasons. One attractive feature of the BLT that sets it apart from many other accounts of natural law is that it allows there to be not just laws and non-laws, but also multiple strata of natural law, multiple varieties of physical necessity. I don't just mean the logical truths, mathematical truths, conceptual, metaphysical truths, other broadly logically necessary truths that are by courtesy counted among the natural laws. They have physical necessity and then some. I'm also counting as laws all of the logical consequences of laws, just as Lewis does, since they certainly aren't accidents. But what the BLT distinctively leaves room for are multiple strata of natural laws that are all modally weaker than the broadly logical necessities, but modally stronger than the accidents. For instance, we might take the conservation laws and kinematic laws and laws concerning space-time structure as stronger than the laws giving the particular kinds of particles and forces and fields and whatnot that inhabit space-time. Let's briefly see how the BLT leaves room for multiple varieties of physical necessity. For any two stable sets, one must be a proper subset of the other. I've sketched the rough argument for this on the bottom of the first side of your handout. Suppose for reductio that gamma and theta are both stable sets, but neither is a subset of the other. P belongs to gamma, but not to theta, and Q belongs to theta, but not to gamma. Then by gamma's stability, P would still have held, had either P failed or Q failed. It follows that Q would then have failed. But this contradicts theta's stability, and we have our reductio. So the strata of laws must form a nested hierarchy. Perhaps then the energy conservation law belongs to a stable set that does not include the various force laws. So had there been an additional force, energy would still have been conserved. Physics has sometimes taken seriously the possibility that the conservation laws constrain the possible forces and the possible elementary particles, let's say. Perhaps the reason why it is that the lightest charged fundamental particle does not decay into multiple other particles is because per reductio, if it had decayed, the conservation laws would still have had to hold. And so there would have had to be a lighter charged particle for it to decay into. Well, that's enough now for the BLT. Our concern is the rule of law, the inference problem. What does that look like under the BLT? If all it takes to solve the inference problem is for lawhood to entail truth, then the BLT solves the problem, and it does so in the same way as any regularity account does. The first clause in the rough definition of stability on your handout expressly requires that a stable set's members all be truths. Despite its non-human character, the BLT solves the inference problem. We're done. Well, not so fast, I think. As I've already suggested, more than lawhood's entailing truth is required to really solve the inference problem. We need something more explanatory in order to avoid being disappointed, as von Frausen says. Von Frausen, all people to demand explanation and not just entailment. And we don't yet have anything explanatory here in the BLT. The definition of stability simply stipulates that a stable set's members are all truths. And this seems like cheating again. Is there an independent way of characterizing stability that would enable truth to fall out of it and thereby explain why lawhood requires truth? And perhaps even shed light on the power of M's lawhood to scientifically explain why M is the case? Let's try revising the definition of stability so that it captures the notion of maximal counterfactual invariance without expressly stipulating that a stable set contains exclusively truths. So from now on, let's remove clause 1 from the definition of stability and see what happens. And now I'm finally turning to the flip side of your handout. I kept seeing you flipping the handout. I was getting distressed that you were ahead of me. So now you can go ahead with a clean copy and flip it over. The BLT can still identify lawhood with membership in the larger set that's non-trivially stable after clause 1 has been removed from the definition of stability. A set's stability is non-trivial exactly when there's a P where the set stability requires that the set be invariant both under P and under not P. Since either P is false or not P is false, non-trivial stability requires that the set be invariant under some antecedent that's false. That is, under some counterfactual antecedent. Non-trivial stability requires that the set be invariant under every counterfactual antecedent under which it could logically possibly be invariant, and that there be some such antecedent. So under this revised definition of stability, truth is not expressly required by membership in a non-trivially stable set. We haven't inserted truth separately by hand into the definition of stability. Nevertheless, any non-trivially stable set contains only truths. If a given set is not logically consistent, then nothing is logically consistent with it, so it could not be non-trivially stable. So take a set that is logically consistent. Let P be a logical truth. P is logically consistent with the set. If the set's stable, then by the definition of stability, P box arrow M holds for any set member M. But since P is a logical truth, P box arrow M entails M. So the set stability entails that each of its members is true. Thus, for the BLT to entail that lawhood requires truth, the BLT does not need to stipulate expressly that a stable set contain only truths. Does the BLT now solve the inference problem, namely by the first root on the second side of your handout? Well, we just got M's lawhood to entail M's truth by M's being entailed by P box arrow M for a logical truth P. But since P is logically true, I worry that when M is a law, P box arrow M holds in virtue of M's holding. In that case, M's truth would be responsible for P box arrow M, which is supposed to be part of what makes M a law, and is supposed to help M's lawhood entail and explain M's truth. In which case, M's truth seems to lie at the bottom of the capacity of M's lawhood to entail M's truth. And that was one problem with using the BLT's original definition of stability to explain why lawhood entails truth. Another concern is that many truths, laws, and accidents would still have held under a logical truth. It isn't really M's lawhood that enables P box arrow M to hold when P is a logical truth. It's merely M's truth that enables P box arrow M to hold. And likewise, we can't use this strategy to metaphysically explain how M's lawhood acquires the power to scientifically explain M's truth, since the argument does not exploit anything that sets laws apart from accidents. If this were the only route by which lawhood guarantees truth, then in using M's lawhood to scientifically explain why M is true, we would again be using M's truth to scientifically explain M's truth. Furthermore, if P is a logical truth, then a set's invariance under P is not what makes the set's stability non-trivial. For that, we need invariance under some false antecedent. There should be a way for truth to come from lawhood that depends on the law's stability being non-trivial. In short, we revised the definition of stability so that truth is no longer inserted into it by hand, and that's a step in the right direction. But the route we just took from stability to truth exploits a stable set's invariance under a logical truth. And I'm worried that that's too cheap. Invariance under logical truths should not be the only route by which lawhood guarantees truth if the inference problem requires something more than lawhood's entailing truth. Even accidents are invariant under any logical truth. The conditionals required by stability that reflect lawhood over and above truth are not conditionals with logical truths as their antecedents. Instead, they have antecedents like, had one of the matches in the book been struck, and had the Earth's axis been perpendicular to its orbital plane. The actual laws would then still have been true, but some actual accidents would not. Invariance under antecedents that are not logically true is the invariance that reflects lawhood. So it's conditionals with those antecedents that should figure in the BLT's explanation of why lawhood entails truth. So let's make a second attempt by trying a different route for getting from M's lawhood to M's truth. The laws form a non-trivially stable set, so there's some P where P and not P are each logically consistent with the laws. Whichever of them is true is contingently true, indeed accidentally true. So take that accident, let it be P. If M is a law, then by the definition of stability, P box arrow M holds, and P plus P box arrow M entails M. So we've got M's truth from M's lawhood. Now, this second route does not exploit any logically true antecedent, just an accidentally true antecedent. Well, that's a step in the right direction. However, now P, an accident, is helping to secure M's truth from M's lawhood. That's not right if we're talking about scientific explanation. If M is a law, then M's truth does not depend on any accident. We've again entailed M's truth, but we haven't explained why M is true using M's lawhood. What we've avoided is any aroma of M's helping to explain itself. That's good, that's progress over our first attempt. But we've used some accident P to help explain M. And that's not much better than using M to explain M. The laws are independent of the accidents. After all, the BLT's motivation was that the laws would still have held even if the accidents had been different. The laws have a kind of necessity, and their necessity involves precisely their not depending on the accidents for their truth. To explain why M's lawhood entails M, we should not have to appeal to an accidental truth. It should not be that M's lawhood alone is responsible. It should be that M's lawhood alone is responsible for M. In view of the majesty of the laws, M's lawhood should not require any assistance from a pipsqueak accident to entail M. So our second approach has made some progress over the first approach, though we're still not quite there. But we can tweak my second approach so that it does exploit the law's independence from accidents. We would then illuminate how M's lawhood scientifically explains M's truth and solve the inference problem by metaphysically explaining why M is true given that M is a law. Let's start the same way we did in our second approach. The laws form a non-trivially stable set. So there's some P where P and not P are each logically consistent with the laws. Whichever of them is true is contingently true, indeed accidentally true. If M is a law, then the law's stability ensures that had P held, M would have held, and had not P held, M would have held. But either P actually holds or not P actually holds. Since in either case M would hold, it follows that M actually holds. Unlike on the second approach, we have not specified that it's P that actually holds. That's the tweak we've made. This derivation of M does not appeal to any accident. And that's not all. Those counterfactuals themselves, P box arrow M and not P box arrow M, those conditionals would also still have held no matter what. They don't depend on any accident. Some counterfactuals do depend on accidents, of course. Had I struck the match, it would have lit, but that fact depends on the match accidentally being dry and well made and so forth. Had I moistened the match, then it would not have been the case that had I struck it, it would have lit. By contrast, the counterfactuals required by the law's stability do not depend on any accidents. The nested counterfactuals in the definition of stability see to that. They ensure that the fact that M would have held if P had held would itself have held if Q had held. Not only is the law's truth independent of any accident, but that independence does not depend on any accident. And there's independence from accidents all the way down. The laws would have held no matter what, and that the laws would have held no matter what would have held no matter what, and so on. I'm not going to try to say any more of those. That's why the laws do in fact hold. This derivation of M's truth from M's lawhood reflects the majesty of the laws. This derivation enables the BLT, I think, to really solve the inference problem. Let's remind ourselves of how. First of all, we've derived M's truth from M's membership in a non-trivially stable set, and we've used a revised definition of stability that does not stipulate that a stable set's members are all true. So we've avoided inserting M's truth by hand into M's membership in a stable set. Secondly, the derivation does not depict M as depending on M itself or as depending on some accident P. That's because this derivation exploits M's independence from accidents. It derives M from M's lawhood alone without appealing to any further premise P. That's how this derivation avoids depicting M's lawhood as needing to be supplemented by some accident in order to scientifically explain why M is true. And thirdly, unlike our first derivation of M's truth from M's lawhood, our third derivation avoids appealing to M's invariance under antecedents that are logical truths. Instead, we've appealed to the truth of conditionals like, had I struck the match, the laws of combustion would still have held. These are the antecedents under which laws differ from accidents in their invariance. So they are the conditionals that should figure in a solution to the inference problem. Was that, you're telling me I had about 10 minutes? That very subtle gesture? I almost didn't notice. We're fine. On the BLT, M's lawhood is constituted by M's membership in a non-trivially stable set. In other words, in a set that's non-trivially possesses maximal collective invariance. The members of a stable set are collectively as invariant as they could collectively be. And because they're maximally unavoidable, the set's members deserve to be characterized as possessing a kind of necessity. And any hypothetical circumstance that's logically consistent with them possesses the corresponding variety of possibility. The third root shows that if M is a law, then M would be true no matter which of these possibilities were realized, which itself would have been true no matter which of these possibilities were realized, and so on. So one way to summarize this third derivation of M's truth from M's lawhood is that the law's truth follows from their necessity. The laws hold because they must hold. Unlike the universal's account, though, the BLT gives an independent characterization of the law's necessity, namely in terms of their stability. The BLT explains why that characterization deserves to count as describing a variety of necessity. And then the BLT derives the law's truth from that characterization. So as you know, I'm rapidly coming to the end. So let me make more explicit what I've been taking to be one important criterion of adequacy for any successful solution to the inference problem. Whatever it is that solves the problem, whatever it is that makes M's lawhood explain why M is the case, It should be something about laws in particular, something not possessed by accidents. Even though accidents are also truths, the accidental character of some fact Q does not explain why Q is the case, whereas M's lawhood does scientifically explain why M is the case. Whatever it is about M's lawhood that explains why M is the case, there should be no analog that's part of Q's being an accident. The BLT satisfies this desiderata. If M is a law, then various subjunctive facts capture M's inescapability. And as we've seen, these are the facts that ensure that M is the case no matter what. An accident does not belong to any non-trivially stable set, and so it's not inescapable in the way that a law is. Though an accident is true, there is no majesty of the accidents, analogous to the majesty of the laws. For an accident, there's no, as it were, mechanism ensuring that it's true that's analogous to the mechanism ensuring that a law is true. Not all accounts of natural lawhood can make this boast. Take a divine command theory of laws, which says that the laws are God's commands to nature. It's a non-Humean account, just like the BLT. Indeed, non-Humean accounts in general have sometimes been characterized as deriving whatever attraction they may possess from their implicitly treating laws as if they were God's commands to the natural world. And this characterization is not intended as a compliment bestowed on non-Humean accounts. Now, the divine command account addresses the inference problem by appealing to the idea that whatever God says goes. So if God commands that M, then M is the case. But the accidents, at least some accidents, are also supposed by the divine command theorist to be products of God's commands. Presumably, when God allegedly creates the universe, God not only establishes the laws, but also establishes the initial conditions. Those initial conditions, at least the universe's initial microstate, that's an accident. But it's equally a product of God's commands as the laws are. So both the laws and some accidents are true from being commanded by God. For this reason, a divine command account fails to satisfy the criterion of adequacy that no accident is made true by the same mechanism that ensures that a law is true. Or to put the point another way, the lawhood of the laws is idle in the explanation of their truth that's given by a divine command. It's God's command, not lawhood, that does the explaining, whether we're explaining the law's holding or some initial conditions. That God commands it to be both a law that M and an accident that Q makes both M and Q come to be true. In exactly the same way for both M and Q, whatever God says goes. This again illustrates that non-Humean accounts can differ in how well they respond to the inference problem. Let me conclude with one final thought. The third derivation that I used to derive M's truth from M's lawhood, the one that I said allows the BLT to resolve the inference problem, that derivation depends upon the existence of some P where P and not P are each logically consistent with the laws. The existence of some such P is ensured by the non-trivial stability of laws. If there's no such P for a given stable set, then the set's members suffice to determine every fact, in which case no counterfactual antecedent is logically consistent with the set's members. And so there's no counterfactual antecedent where their stability requires their invariance under that antecedent. The BLT ensures that the law's stability is non-trivial by deeming the laws to be the members of the largest stable set apart from the set of all truths. In other words, the BLT requires the law's stability to be non-trivial, and in so doing, the BLT requires that there exist some accidents. This aspect of the BLT sets it apart from many other accounts of lawhood, which do not entail that there must be accidents in order for there to be laws. I take this aspect of the BLT to be, you guessed it, a feature, not a bug. A satisfactory account of lawhood should entail that there must be accidents, that it cannot be that every truth holds as a matter of law. As that great philosopher William Schwenk Gilbert wrote in his 1889 treatise, The Gondoliers, when everyone's somebody, then no one's anybody. The laws can exhibit their stability in connection with counterfactuals only if there exist some accidents, so that the laws are invariant over counterfactuals positing different accidents. the rule of law requires that there be something for the laws to rule over.
I point to you and introduce it to you. And Barry first.
Mark, prior to this talk, I thought the BLT was toast.
Where's David and something about puns?
In a number of things that's in my mind, but seriously, I can see how you sort of turn the world upside down in a way. And the way I thought about once before, I remember we had an interaction about this, was you're putting the cart in front of it.
Yes, I thought that was very
It
clever.
looks to me like the cart.
I'm sure.
The cart is pulling some things, which I didn't realize before, but I wondered from the past, right, how you think about counterfactuals, all the counterfactuals are there, so to speak, before, they're what's fundamental.
Well, they're before, and they're before a lot of other things. I didn't say they were fundamental. I think I may have said they were more
I want to say
fundamental.
more about that, but I'm wondering what structure they need to have in their account. I mean, is there a logical structure? For example, the usual counterfactual theories like Lewis's big areas of metaphysics, the counterfactual structures built in by similarity. Turns out, not a very good account, but it works out. And a probabilistic account, you get a structure. Probabilities. Just wondering what's the.
Right, I've tried to make as few presuppositions about the semantics, the fundamentality, the truth makers of counterfactuals as I could get away with. I'm trying to be as ecumenical as possible. There are a few constraints that I imposed along the way. I had, for instance, P box arrow M and P entails M. I had that one. I didn't have centering, that is to say, P and M entails P box arrow M. I didn't have that one. Lewis has that one. So there are some things that I needed to get stuff off the ground. If this had been in more detail, I would have had some relation between a box arrow and a diamond arrow, because everything really should be done in terms of diamond arrows here rather than box arrows. But try to make this go down easily within the time constraints that I had. So there are some, obviously, some presuppositions about the structure of the counterfactual field, but I didn't presuppose the counterfactuals were fundamental. I just have to put them before,
But you
well,
didn't say-
lawhood and
You didn't say
necessity and
anything more about
explanation.
it,
No, I didn't. I mean, I'm,
because you think you can get away with it.
well, I'm hoping to. I mean,
Yeah,
there are
yeah.
some, I have my own, prejudices here like anyone else. But
I
I'm
wanted to say
hoping I
this
can
one
get
other
away with it.
thing about the God command, this is what you were talking about, it's a lot of fun to talk about. The way it's done though, that God just commands the laws. He then has sort of one of his angels, goes and sets initial conditions. And then the rest is, so that's a good line.
Well, I mean, if God deputizes the angel, then it's God doing it with plausible deniability.
Angels have free will.
Yeah, this may be a related question. So I was worried about whether the stable set would exist, and even if it does exist, whether it would actually lead to the law, what regards the laws of nature. So
I'm sorry, I didn't quite.
sorry,
hear all-
two related worries. One is whether a stable set exists. And we like to have, nice to have a proof that it does exist. Another is that even if it does exist, whether that set isn't going to be the set of laws. Now, let me just try to make this worry more concrete. I mean, suppose, take the actual world, and suppose there's a world closest to it. We could just look at that proposition that either the actual world holds or this other world holds, and then look at all the logical consequences. I think as I've set it up, that would be a stable set. If there is a non-actual world that's closest to the actual world, I think that would be
A unique,
yes, yeah. So anyway, I'm just giving you that as a concrete illustration of the kind of worry you might have as to,
Right.
first of all, whether this thing exists because, and whether it actually, if it did exist, if you thought there were this world, you might think, well, that goes far beyond what we want. That's building a lot more content into the laws of nature than we really want there to be.
No, I share all of those worries. I have tried to derive from this apparatus, metaphysically rich, though it is the result that a non-trivially stable set exists. And I haven't managed to show that, and I can't decide whether that's a good thing or not. I mean, must there be laws of nature? Is there some reason why there have to be laws of nature? I'm not sure. Though I certainly would find it interesting if I could. I'm sure I'd make a virtue of necessity if I could find a way to do that. Remember, though, also that you asked if it does exist, is it the set of laws? Remember, I'm claiming that the laws are the largest non-trivial stable set. So
Right, yeah, I meant not.
Okay, you hadn't said
Yeah.
it, so I.
Yeah.
Sure.
But take that particular case when, imagine now that there were a world that's a unique world closest to the actual world. Then that defines a stable set, I think, at least if you accept like the Lewis. I mean, just for the sake
Yeah,
of argument.
I think.
And intuitively, you might think that even if there were such a unique closest world, there's no reason to think that the laws of nature would simply consist in either the actual world holding or this other world holding. So,
Right.
yeah, so that would give you reason to doubt that the stable set is going to give you the law.
Well, I guess part of what I would need, if that's right, part of what I would need in the structure of counterfactuals is that there isn't a uniquely closest possible world to the actual world, or, as I mentioned very quickly to Barry, that the actual world is not the closest possible world for, I mean, as I say, I don't accept centering, which, that if P is true and Q is true, then P box arrow Q is true.
I think the point can be made without presupposing. the
Without
Lewis approach.
presupposing.
Yeah, they could.
Because you were starting,
I presuppose the semantics here. I think the point can be made purely counterfactual terms. That is, there's some kind of. Sorry, I
No,
don't,
go
okay, you got the world,
I mean,
you got the actual world W and this other world W prime,
Mhm.
and now what we want is that if any proposition. Think of proposition that sets of worlds,
Okay.
any proposition containing W prime poles, but not W, then W prime would have to be the case. So we could state in counterfactual, something like that. We have to say in counterfactual terms. How things, so it would be a matter of there existing certain propositions,
Mhm.
there's certain counterfactual behavior from which it would follow. Sorry, these are world propositions. So we're taking.
No, I understood that.
Yeah, okay.
I mean,
So-
not even the whole world, just
Yeah.
as it were, subnomic facts in
Yeah,
the world.
Yeah.
Because I would
Yeah.
rule out as relevant counterfactuals here antecedents, like had energy conservation not been a law.
Right.
For example, so I took
Yeah.
it, those were the propositions you had in mind.
Yeah.
Well, I'm gonna have to think about how maximal and non-trivial and legitimate those propositions are and see whether that would
Good.
turn out to be a largest non-trivially stable set. I wouldn't want it to happen so cheaply.
Great, thank you. Yeah, so I guess you already brought this up, but you were kind of assuming notice elements for kind of factors. And I was kind of.
Well,
thinking-
that raises a whole bunch of other things.
Great.
But why don't I see where you're going
Sure.
before I say it again?
I guess I was thinking that's just the inference problem. You kind of relocated it to kind of facts, and then someone like Lewis should say, I just can't see it. If there's this counterfactual fact out there, like P, then box arrow Q. And P, I just don't see how that counterfactual fact together with P could make it impossible at Q. So I'm thinking if you thought that kind of complaint was legitimate, then you should say it here, and you should say, look, you named it counterfactual and used this familiar locution.
Yeah, I can see how you're riffing on the very same
Right.
passage.
So then, I'm thinking, well, maybe the idea is that this is somehow better because it's like, either because it's a concept we already had, or because it's logical, and I'm thinking neither of those is very satisfying, because fact that it's logical, maybe I could then propose that N was a logical relation and that this was part of its logic. Or that the fact that it's a familiar concept just doesn't seem like it should do that metaphysical work, because maybe I can invite you to have this new concept and to kind of make it a priori under this new concept that if NFG, I get that. NFG. So yeah, I'm wondering why you think there's progress by relocating it.
Well, I mean, if it were merely relocating the problem to accounting for how P and P box arrow Q entails Q, then that was all that was accomplished. That would be pretty thin stuff. I still take that. I don't think I would want to avail myself of the other remedies that you mentioned. You know, there are a whole bunch of desiderata for a successful account of lawhood, and it's impossible to make some sort of argument that, well, you know, this alleged advantage is so advantageous that it makes it worth swallowing that apparent disadvantage. And, you know, that's part of what's enjoyable about the literature in this area. You know, different people are going to weigh the advantages and disadvantages differently. So I don't mean to suggest that what I'm going to say in a moment ought to just strike you as an obvious top-down consideration. But I do think that it's advantageous for an account of lawhood not to have to give some special ad hoc explanation of why whatever it is you think laws are, those things are invariant under counterfactual antecedents in the way that I was describing. Now, of course, it'd be one thing if I was misdescribing the invariance of laws under counterfact. And that's I have that worried about it for a long time. Maybe someone will want to talk about that. But if that is the distinctive counterfactual invariance of laws, then I think it's great if that is built into what law is, rather than having to be argued for in some rinky-dink way. Well, if you've got NFG, or if you've got the best system, which is a trade-off of this and that, or if you have the best package or whatever it is, then naturally the regularities in that package are going to be invariant over the relevant range of counterfactuals. I think it's much better to build that invariance in from the beginning. This is the thing I wasn't suggesting you should find to be a knockdown argument. Build that invariance in from the beginning and then see how much stuff you can get out. And if you can get enough stuff out of it, then it's paid for itself. I mean, this is a familiar kind of bargaining that Lewis himself does in this context. And if it doesn't pay for itself, then you rethink what you put ahead of other things. But I think it's nice that you can get necessity and explanation and so forth out of sticking the counterfactuals in at the beginning, and that you don't have to avail yourself of any cock and bull story about how you got that particular degree of invariance. Not more, not less, but just that. It seems to me very difficult to see how you're going to get that out of, well, the other accounts that I mentioned.
This is not unrelated. I guess I'm interested in the setup of the problem and what counts as a good solution.
I did mention that was already going to get me into blended hot water.
I don't think it's hot water. I think it's like enjoyably warm water. I take it the idea is that Lewis and Van Fraassen seem to disagree to some extent on the criteria, and maybe Van Fraassen is also a bit unclear himself, you know, it might be different. So under what you would recommend as maybe the best criteria to use here, I'm curious if the following is an okay solution. I just say that the lawhood of M scientifically explains M's truth. I'm sort of stipulating this is the case of scientific explanation, but it doesn't feel like I am merely stipulating it, because I am, you know, telling you that it's scientific explanation and maybe giving you some clues for further investigation, yada yada. Good or bad, you know, is this sort of a plausible route under the way you're thinking about it, or is it no? It's like
no, I mean, I'm just thinking about it now, but it seems to me that it's, shall I say, an admissible option. I mean, first of all, you're getting the entailment. I take it. Maybe you need to say a little more about what sort of scientific explanation you have in mind here, is not a statistical explanation, but I'll grant all of that. So you're getting the entailment, that's a minimum criteria. You're obviously getting the scientific explanatory relation between M's lawhood and M's truth. And of course, you're getting it very quickly, which you could regard as cheap or you could regard as elegant, depending upon which way you look at it, but you're getting it, right? And are you getting a metaphysical explanation of why M's lawhood scientifically explains M's truth, or why M's lawhood entails M's truth? Well, this takes us back to, is it elegant or is it too much theft over honest toil? I don't know. I mean, the way I would think about it, I mean, you asked me if it meets those desiderata. I would go back to the earlier question, I think it was the previous question, and say, all right, you got scientific explanation out of it. Can you get the other things that we want to get out of M's lawhood? Necessity, variance under a certain range of counterfactuals. What other things would you like to get out of? I mean, those are the ones that immediately come to mind. You put explanatory relations first. Can you get those other things without icky ad hoc band-aids? Well, it was your suggestion, so I'm not going to try to figure that out. But yeah, I think it's a legitimate option to try.
Great. I really enjoyed the talk. I'm sympathetic to the line of questioning that's coming from Barry and Veronica. So I'm going to sort of move along that line. One of Lewis's complaints against Armstrong was that if Armstrong made certain moves, he was just adding things onto the regularity theory. Plus, there is a special relation. And one of your moves made me worry that you might be doing that, but it's not clear to me because I'm not sure how independent the conditionals are supposed to be from the facts. And the move that made me worry about it was your rejection of the first route. So you said, look, if I take this route, you might think I'm being cheap because you might think that M's truth explains why M counterfactually follows from tautologies. But I kind of wondered, why would that be if the counterfactuals are in some way metaphysically independent of the truth? I would only expect the truth of M to explain why tautology counterfactually tells M if somehow the counterfactuals were defined in terms of the actual facts. Does that make sense?
I think so.
Yeah, so I'm worried actually that by responding to this imagined objector in the first round, you're already kind of buying into some of the Humean complaints that you've got to define your counterfactuals in terms of what actually happens in the movie.
Yeah, I didn't take the claims to really presuppose Humeanism at all. Yeah, independently. Whether the complainers were Humeans themselves or not, is neither here nor there. Yeah, I mean, I have worried about whether it was a too quick dismissal of that, whatever, logic. P is a logical truth and P box arrow M comes too easily. So I'm not sure that I'm right to dismiss that as quickly as I did. That was part of the reason why I gave 3 or 4 different reasons for dismissing it, which is always a good sign that, I mean, if someone had a really good argument, they would have just given 1. I gave 3 or 4.
Yeah.
Guilty as charged. I guess the thing that weighs with me most in putting that route aside is its dependence on counterfactuals with logical truths as their antecedents. Yes, I'm thinking that if you were teaching the difference between laws and accidents to a group of new students, and among the differences you came to differences in their relations to counterfactuals, you wouldn't use as your illustration something with an antecedent that's a logical truth. You would use, had I struck the match, the laws of combustion, or something in that Goodmanian neighborhood. And so it seems plausible to me that the explanation of why M's lawhood explains M should also go through that kind of counterfactual. Now, of course, if you choose one of them in particular as what it goes through, then you're on the other horn of the problem, right? Now you're making the lawhood somehow tie to an accident in deriving the law's truth, and that's no good either. And this is the story again, but it's closer because it deals with, you know, a counterfactual. That's the sort of thing that you would use to illustrate the difference between laws and accidents in their relation to counterfactuals. So that's the argument that moved me the most. I don't know how it strikes you.
I'm sorry,
Michael.
So I want to know more about what kind of explanation this is. So let me say a little bit more what I mean by that. It has the surface form of a logical derivation, as many explanations do. Of course, you don't think logical derivation is enough. You reject a couple of logical derivations as not being explanatory. So it's got to be
Well, not all of them, anyway.
Right. So when we see sometimes when we see a logical derivation and an explanation, what it's really doing is just standing in, as it were, for something in the real world that is a real explanatory relation, a causal relation, for example. Some people who think about metaphysical explanation in the same way, that what the logical derivation, if this were a metaphysical explanation, that logical derivation would have to stand in for some metaphysical relation in the world that's doing the real work. I wonder if in the light of your desire to reply to Van Frassen, you might want to shy away from that option. Which brings me to a third possibility, which is that it's not really standing in for some other dependence relation, but in fact, and this resonates a little bit with the way you talked about the reasons for going with option 3, but it's more like the way you think about mathematical explanation.
That's what I was going to say. I mean, go ahead, keep going, tell me more.
Let me wrap up by saying, isn't it strange that the explanation of why the laws imply the regularities is a mathematical explanation?
Well, I wasn't going to quite go that. So what I was thinking in the mathematical explanation line was that, of course, it seems to me that all of those roots, each of those roots, is sound. I mean, each of them gets you to where I said you need to go. And it's a question of the root that distinguishes, so I'm suggesting, a genuine answer to the inference problem from a mere, well, we got the entailment, we got there. We got to M from M's law. And that's why I was thinking of the case of proofs in mathematics. I mean, this is a whole separate interest of mine, at least I thought it was separate until a few moments ago. According to me, in mathematical practice, there's a distinction, or at least a spectrum between proofs that explain why some theorem holds and proofs that merely prove that a theorem holds. As I say, there could be some intermediate cases as well. And I'm interested in that phenomenon and what that phenomenon is, a alleged phenomenon, and what that phenomenon is all about is the root. And some roots will be more explanatory. And so, just as there are other dimensions in which sound proofs, let's say proofs, can differ among themselves, purity, visualizability, simplicity, generalized. I mean, there are so many respects in which proofs can differ, and I take explanatory power to be one of them. And that's the way I was thinking of the differences among these roots, that some of them are more explanatory in that kind of way than others. Now, what is that kind of way? That's a whole other story that I'm going to restrain myself from getting into. But that was the way I was thinking of it, and I gather you were generously offering me that option. I don't know how it strikes you, but you might not even recognize the alleged distinction or spectrum between explanatory proofs and math, mere proofs. So that may not be a useful analogy if you don't either come with me that far.
I do, no, I do recognize it, and you call it an analogy, so maybe that's a way of backing away from.
Right, that was why I reacted with
Full-blown.
horror at the end there. I didn't think of it as having to fit the same conception of explanation that I would use in thinking about what makes certain mathematical proofs more explanatory. Because I don't see it as having to have whatever those properties are that make a proof more explanatory, but just the possibility that the root will some roots will be more explanatory than others. That was the piece of it that I was grabbing to.
Can I recast my final question then as one about the suitability of just in logical entailment alone for the work of actually explaining, the world around us with all its patterns and so on. Is just entailment, even if we restrict it to the sort of right kind of entailment that picks up on the appropriate properties of the explainer, the laws in this case, is that really powerful enough to deliver the universe?
I don't think I was committed to saying that. I mean, even in my whole book on non-causal explanation in science, I didn't suggest that entailment was enough. Even entailment between equally necessary laws of nature, let's say. Several different laws, each can entail the others, let's suppose. So they all have the same counterfactual degree of invariance, but I suggested in various places in that book that some of those were explanatorily prior to others, or at least had been commonly regarded as such in the history of science. So I hope I wasn't committed to saying that mere entailment was sufficient.
Yeah, we move on to the next one.
Thank you, Mark, for your interesting talk. I like the new name BLT. In my book on laws of physics, I call your view Lange reductionism, but I should have called this something like BLT. I like BLT star.
You can use it in the second.
The second position. BLT star, I think, is a really cool attempt to try to solve more problems with the existing resources, with even fewer resources than before. And one key distinction you make is between the largest stable set versus the largest non-maximal or non-trivial stable set.
Gotcha.
And this, I think, lies a key disagreement between you and me, maybe you and the rest of our people in this room who work on laws of nature. As you say in your paper with Chris Dorst, that maybe only you and Chris have the view that preserve this non-trivial, non-maximality distinction as a metaphysical necessity. So strong determinism, for example, is ruled out a priori by this view of laws, by this necessity of the accidents. So this, when I teach your view to my students and teach here with other physicists, and I raise this worry, and it seems to be, somewhat troubling from a naturalistic point of view, that there are existing proposals in quantum cosmology, quantum gravity, and quantum theory in general, strongly deterministic theories with a unique fundamental history that's being physically possible. So really, only one world is physically possible. And Hawking, Lange, Page, my version of everything like calculus, all of them are compatible with exactly one nomologically possible history. And that will be ruled out as incoherent, unintelligible, wrong, mistaken, naive student. And okay, wow. All right. So there's stop. Right. Okay. So this is playing a key role in the argument here. And the
well, it's a consequence of the argument.
Yeah. I understand the conceptual argument about hesitations, about language use and explanation. But then the naturalistic pressure is to preserve certain way of doing physics as metaphysicians, we try to differ a little bit at least, right? It's that there are things that are coherent and non-contested, but we try to understand what's going on with laws of nature. So we don't try to impose too much from our armchair to the practice of physicists. So I was wondering, do you have any thoughts?
Well,
say more about naturalistic kind of examples?
I'm at this level of generality, I'm not exactly sure what to say. I think you're right that. So he was alluding to a paper that's coming out in JPhil sometime that Chris Dorst, a former student of mine, and who's now at U Florida Gainesville, and I wrote, which Jay has seen a copy of, which could be sent, Chris sent, where we independently from any of the considerations I was just discussing today, argue that there must be accidents if there are laws. It's got the catchy title, The Necessity of Accidents. And I thought it was catchy. And I do take your point that, well, that there aren't that many accounts of lawhood out there that require that there be accidents in order for there to be laws. And that I think that many philosophers who work on laws would say that, I guess there could be, as it were, exotic worlds, or maybe it's the actual world where there are laws but no accidents. Chris and I don't, of course, just declare from our podium that there can't be laws without accidents. We have arguments for this that have nothing to do with the arguments here. But basically, the thought is that in order for laws to play their law-y roles, the roles that distinguish them as laws, there have got to be accidents. And I think those are very good arguments, and I quail at the prospect of scientists who think that their theories are theories where there's only one physically possible.
I mean, there's this
world,
fundamental world and derived world. In average, for example, you have coherent histories, multiverse scenarios, counterfactuals can play different roles. There's only one physically possible history. With multiverse, there could be branches and so on to the role of counterfactual possibilities.
Well, maybe Chris and I and those physicists are talking past each other when we each insist on what the laws could be like in such worlds, or whether there could be worlds where there are laws but no accidents. I'm not as familiar as you are with scientific literature.
It's relevant to this non-triviality point, which is built into the illusion.
Yes, I mean, I thought of you when I put that last bit in the talk. I see my arrow has hit its mark, hit its heading. So great. It's a provocative thesis.
Yeah, thanks. Really great. A lot of Michael asked about half my questions, so I'll ask the other half. I get the big picture questions. I am just curious to hear more about the notion of explanation, working with the criteria for what counts as good or a successful explanation. One set of criteria could be appealing to counterfactual, like explanations need to be backed by counterfactual. And because you have a very robust notion of counterfactual with levels, I kind of thought you have the resources to appeal to that, whereas people who are more squeamish about impossible antecedents might not be able to. I also thought pertinent to the mathematical explanation case, well, I'll tell you what you think, but
no, I'll take notes.
As I understand the view, symmetry is really important to explanation, unity, that kind of stuff.
So you're talking about now explanation in mathematics.
Yeah.
I don't want to say mathematical explanation. That sounds like it. That can be ambiguous between a scientific explanation that what I call distinctively mathematical scientific explanations, like mother fails to divide her 22 strawberries evenly among her 3 children without cutting any because 3 doesn't go evenly into 22. That's a scientific explanation, but it uses math in a special sort of way. Then there are explanations in mathematics, which is what we were just talking about a few minutes ago.
Yeah, and I was thinking that it was interesting that it arose that there do seem to be a lot of symmetries in the explanations you were proposing. I mean, the point about either PN P would M or not PN, not P would M, and also, Q and P and Q would P would M and all the permutations of that. That's a deeply sort of symmetric structure you've identified, which does seem to kind of fit nicely with some of your views about explanation. So anyway,
well, I mean, I hate to throw away the gifts that you're bestowing on me, but I guess that's what I'm thinking about doing. Yes, I think that in certain contexts in mathematics, when a mathematical result displays a striking symmetry, a proof that respects that symmetry is going to tend to be more explanatory than a proof that just bulldozes its way through in a brute force way and doesn't exploit the symmetry in the result. I mean, that's putting it very, very loosey-goosey way. But I wasn't thinking of any of that as playing a role in this discussion. I was thinking of the explanations here as either purely scientific explanations. The lawhood of energy conservation explains why no one has ever succeeded in creating a certain sort of device. Or a metaphysical explanation where, you want to avoid ad hocery and other sorts of ills, but symmetry doesn't play a particular role in it. So, I mean, I wrote down what I'm gonna have to think more about whether that's the way I want to go, but I wasn't thinking of symmetry or any of the other features that I've argued tend to be salient when they're present in mathematical theorems as playing any role.
Yeah, so I was wondering, you explained,
I just want to hear you better.
yeah. You explain, use these features of counterfactual to explain why they rule. But my question is, why can't other and non-human and the human accounts still use your explanation? Because on other and the human accounts, the laws don't count for counterfactual, but it's still going to entail very same counterfactual. So suppose I'm an explanation from a law, count the measure of mass or whatever. I'm still going to have the very same counterfactual that you have, and the same stability and the same features. Then they say, and then once I have them, I'm going to use the very same derivation you give. So I can still explain why it's
No, I'm totally with you on this. If another kind of account, whether Humean or non-Humean, could take advantage of the alleged explanation that I've given, that's I don't have a trademark on it. It seems to me if it can be subsumed easily into that account, a dispositionalist account is a good example. That's fine with me. Then they could solve the inference problem too, and my account wouldn't have bragging rights in that regard over that account. Now, I mean, you didn't mention Humean accounts as being able to do it. It seems to me that if a Humean account had a non-ad hoc way of getting the range of invariance that I think is distinctive of laws, then a Humean account could use it too. I don't happen to think that the standard Humean accounts on the market can get that range, that distinctive range of invariance, except in a kind of build it in by hand sort of way. But if they could, bully for them, and they can make use of the same argument.
Yeah, thanks. Yeah, my question is also on the ELT specifically, and I take it has been around for a little while, so I'm not sure if these are novel things, but I'm encountering for the first time, so I'm going to raise them anyway. I guess the first question is, you were both highlighting kind of the importance of that you assign special status to the largest non-trivial stable set. But then you were also at some points in the talks kind of happy to assign, status of lawful propositions to smaller sets than that. I have a worry for both positions. Let's take the position where you are happy to kind of be pluralist, kind of grant a lawful or a special status to range of non-trivially stable sets. I'm worried that that just will include too many sets, even sets that contain what seems like very contingent propositions. Here's the case, if the laws are deterministic, then the conjunction of the dynamical laws together with any proposition that's strictly weaker than the initial condition will be a non-trivially stable set. So I don't know, specify a patch of the initial time slice, proper patch, together with the dynamical laws that will, the logical closures that will be a non-trivially stable.
And that will be I'm sorry to interrupt, that will be a non-maximal?
That will also be a non-maximal, exactly, because you only specify the initial part of the initial.
Oh,
condition.
part of the initial,
Exactly, yeah,
oh,
that's-
sorry,
And
sorry,
any proposition that's strictly weaker than the initial.
sorry.
Good, so it's the first case in the deterministic. If the laws are indeterministic, then it's even kind of worse. Take any complete history up to a time, provided there are some stochastic events happening in its future. The conjunction of the complete history up to the time plus the indeterministic dynamical laws will also be a non-trivially stable set, because there will be propositions in the future whose where both the proposition and its negation will be compatible with the set, so it will be and provided you are kind of non-backtracking about counterfactual.
Ah, well, I was wondering about that.
Okay, good. I mean, in the indeterminate, we can talk about this in the deterministic case. In the indeterministic case, I mean, backtracking, I don't know, even if you are.
I'm very open, broad-minded about counterfactuals and their context sensitivity. I mean, that's a reason to worry about certain things, but in this case, it means that I'm fully on board with the possibility of contexts where backtracking counterfactuals are perfectly kosher.
If you have genuinely indeterministic laws, I mean, there will be very little temptation to be backtracking. If, you know, I flip the coin, it actually comes up heads, and then you say, oh, if it came up tails, I don't know, there's no, you can hold the laws fixed and accommodate the coin coming up tails without having to backtrack at all. So
Well,
I'm
you
not sure.
can. I mean, that's not the way counterfactuals work, though, right? Had I struck the match, it would have lit. Of course, I could accommodate it. It's not lighting in all sorts of ways, but it's still true that had I struck it, it would have lit. Or, I mean, bracketing certain concerns about any counterfactual at that.
You want to have some constraints on the allowable conversational context. I mean, otherwise I can, there will surely be conversational context where some nomically contingent proposition, if I negate it, I will land in a world that's nomically impossible. I mean,
Well, that's absolutely a worry. And that's the sort of worry I invite. I open myself up to when I say I'm very broad-minded about counterfactuals, and there are all sorts of contexts where all sorts of counterfactuals hold.
But
You know, all I can say is, I've tried to construct cases like that, and I found either principled or ad hoc ways of figuring it out, depending upon how, I mean, obviously, I think they're principled, but I can imagine somebody.
Just one last time, because I know
I took his time.
Sorry, the indeterministic case is also a case where there is no largest non-trivial set, because you can always add, you can always extend the history a little bit, and you know, and there will be no largest. Once you include all the history, you will be in the trivial case,
Right.
but you can up to that you can always add something.
Good. I will think about it.
So we time's up, but we have only one question, so please make it quick.
Yeah, so you cited the reason to decide between these three routes that, well, some of them are more explanatory than others, even if they all get you M. And then there was some kind of difference to the case of mathematics where some proofs are more explanatory than others. And I wonder, like, what kind of cases we're talking about, because, for example, in mathematics, a proof can be more explanatory because it connects, you know, many areas like topology with like algebra or whatever.
Well,
And then if we have
can do that,
subdivided
whether that-
mathematics differently,
Whether that would make it more explanatory.
right,
or
if
not.
we had subdivided like areas differently, other proofs would be more explanatory, or sometimes in mathematics, there's like really long proofs produced by computers, and we say like, oh, this is not explanatory because we don't have like big brains to, you know, go through the proof. But if we had big brains, we would say that they are explanatory. So I mean, so there's a sort of like, there's a notion of a proof being explanatory that highly depends on how we are. And I wonder if that's the notion that you're using here, or some other notion. So yeah.
No, I mean, first of all, it came up by way of an analogy. At least that was the way I was thinking. I wasn't suggesting that, what I was taking to be an explanatory rule was explanatory in the way that, in precisely the same way as, in my view, explanatory mathematics. Now, what you've just done is highlight a number of the challenges that immediately arise if you start thinking about certain groups in mathematics as more explanatory than others, or as explanatory in a certain way rather than in a different way. Whether explanation in math is somehow a reflection of what other stuff you're familiar with in math. Well, I mean, that's sort of what makes a proof maybe pedagogically more useful, or gives you the aha experience or something like that. But I don't take any of those in math or science to have to do with explanation. I've had the experience since we're here at Rutgers, I've met some psychologists in the Rutgers Psych department who do these studies of mathematics students or mathematicians or budding mathematicians, asking them to say, is this proof more explanatory? Is that proof more explanatory? Rate it from 0 to 5 on a, you know how these psych experiments go. And I find all of that stuff incredibly unilluminating from my point of view, because there's no stage setting, or very little, as to what is meant by explanation. You know, because we all use the word, I mean, it's one of these famous words in philosophy of science, we all use it to mean many different things that don't have anything to do with scientific explanation or my life's explanation in mathematics. Without that kind of stage setting, you're going to get totally bogus answers to the question of whether this proof is more explanatory than that proof. It's going to reflect length and background knowledge and all sorts of things that are irrelevant, that everybody in this room, I take it, thinks is irrelevant to scientific explanation. I mean, don't correct me if that's not the case, but so I'm not sure what to say other than that it's a complicated subject, and none of those considerations that you mentioned is the sort of thing that I would say is part of explanatoriness, though some of them are important in mathematical practice.
Okay, this is it. Thank you so much.
We will take a 10-minute break and we will return for Tim and a group photo and possibly even